Hi, welcome to 3.4. We're going to go over common functions and piecewise functions. I call common functions parent functions sometimes, and that is because after this lecture, we're going to talk about how to change or translate a parent function by putting a number in front of the x, putting a negative sign in front of the x, adding a number at the end, at the back, something like that. So these are called parent functions because these are the foundation. And then in 3.5, we'll talk about how to change the parent function a little bit, but they are also called common functions. So that's the title of the lecture. I would recommend, didn't know where I was going with that sentence. I would recommend using Desmos frequently for this, okay? So first, we're just gonna start out by graphing. What does it mean when they ask us to graph something like y equals a number? Remember that y equals is the same as f of x equals, okay? So we'll go over common functions or parent functions, and then we're going to go over piecewise functions. A piecewise function is when you have maybe f of x equals 3 up until x equals 0. So for when x is less than or equal to 0, our equation is f of x equals 3. And then maybe after that, when x is greater than 0 or greater than or equal to 0, it becomes f of x equals x and starts doing something else. So a piecewise function is going to look different. It's going to be two different functions depending on where it is on the x-axis, which is confusing, but you'll see a visual of it and that will make sense. All right, to start with, we're basically creating a table of values, of x, finding y or finding f of x, and then plotting those points so that we can graph. Again, use Desmos if that comes easier to you, if that's simpler. The numbers I'm going to try to stick to using are -2, -1, 0, +1, and +2. Because those are small numbers, you can graph them kind of easily because they should be right along here, okay? So all this equation says is y equals, and then a c for constant. Y equals a number. We've covered this. When y equals a number, oh my goodness. When, I just noticed that I have a broken straight edge. When y equals a number, it's going to have a slope of 0, and it's just going to be a horizontal line, right? So there is not even an x for our equation, but if x were -2, y would still be 3, so that point will be -2, 3, right? When x is -1, y is still 3, so -1, 3, and I think you can see where this is going and why, in some circumstances, Desmos is faster. As I make mistakes while I try to talk and write at the same time. When x is 2, y is still equal to 3, so that's just going to be the point 2, 3. Here's 3 on the y-axis. So -2, 3 is maybe here. -1, 3, 0, 3, 1, 3, and 2, 3. I can't really reliably make a straight line. Graph the function f of x equals 3 is going to look like this because it's just y is 3 no matter what x is. Now, this is called the linear function. It's going to make a straight line, and it's going to include both y and x, right? Because f of x is just y equals. F of x is x is the same as y equals x. It's just that y equals x is a function, so we can call it f of x equals x. Again, use -2, -1, 0, 1, and 2 for my x-axes. -2, -1, 0, 1, and 2. F of -2 makes y -2. So that point is going to be -2, -2. F of -1 gives us -1. So that's going to be the point -1, -1, because my x is -1 and my answer is -1. When x is 0, the whole function equals 0. When x is 1, my whole function equals 1. If you're feeling the desire to skip this and go straight to Desmos, just hold on 1 second. So that I can show you, make sure you know how to find a table in Desmos as well, a table. So -2 is going to be this guy, -1, -1, 0, 0, +1, +1, +2, +2. So that is a linear equation, y equals x or f of x equals x. Good. All right, let's go to Desmos. Ignore. Oh, so there's a piecewise function. So until x equals 1, it looks like the line 2/3 x plus 1. And then after x, at and after x equals 1, we have -2x plus 1 down here. That's a piecewise function. All right, here was our constant. And here is our identity function or linear function because it's a line. Remember that you can just press this edit list and it will give you the choice to show the table of the equation you put in. So when f of x equals x, when x is -2, y is going to be -2. When x is equal to -1, y is going to be equal to -1. 0, 0. Okay, so they will give you the table of some of the functions we're making here. So when they ask you what is f of 2 of f of x equals x, you can say f of 2 of f of x equals x is equal to 2, which is what we got as well. F of 2 is 2, which is the point 22. Square function just means we took the x value and we squared it, okay? Create a table of values using the same ones, -2, -1, 0, 1, and 2. And remember, those are our x values. So f of -2 is going to be equal to, now we're getting into an actual equation we can work. So -2 squared. Remember your parentheses. Children. All right, I had to pause that recording. Remember to use your parentheses. The square -2 squared needs to have parentheses around it. That's going to give you the wrong answer if you don't use parentheses. Okay, always use parentheses. So f of -2, when we're talking about the square function, x is -2, but y is, we saw, 4. Okay, f of -1 is -1 squared, which is 1. So that's going to be the point -1, 1. 0 squared is still 0. So we're going to go through the origin on this graph. Less important using parentheses when you have the positive. 2 squared is 4. So that's 2 and 4. Okay, so these points are, let's start with 0, 0. That's the point 0, 0. Then we have the point 1, 1. Then we have the point 2, 4. Over here we have -1, 1. And then we have -2, 4. Good. So that is the square function. When you get y equals x squared, it's always going to look like this. On Desmos, here it is, okay? And then what we mean by I'm going to transform it is maybe we put a -3 over here. It gets bigger, or it gets lower, sorry, it does not get bigger. Let's zoom out. Good. So -3 made it lower. Plus 2 makes it higher. X, what if I put some stuff in parentheses? X -1, moved it over to the right. And then maybe 3x squared made it narrower. But you can see that our base function is x squared, and then depending on what we do to it, it changes the look of the original x squared. So that's why it's called the parent function. Again, if you want to find your x values for that, they will create the table for you. There's your table with some helpful values on the table. And that's the graph of it. All right, x cubed. So -2, -1, 0, 1, and 2. F of a -2 is -2 cubed. -2, again, just put it into your calculator. -2 cubed is a -8. Good. -1 cubed is -1. 0 cubed is still 0. Oh, sorry, -1, -1, 0, 0. 1 cubed is going to be 1. And then 2 cubed is going to be a +8. So the cubed root looks very different as a graph. We still are going through the origin. We're still going through 1, 1, but instead of going through -1, 1 like we did for the square, we're going to go through -1, -1, and then we're going to go through -2, -8, +2, +8. So it's more of a symmetry with respect to the origin, whereas this guy had symmetry with respect to only the y-axis. Okay, so that's x cubed. Now the square root function. All we're going to do is take x and get the square root of it. So I'm not going to start with -2 because the square root of -2 is not, oops, I'm sorry, you couldn't see that. Start over. The square root, you already see it though, the square root of -2 is not a real number. So I can't even graph the square root of -2. And the square root of 2 is going to be a decimal. I don't want that. So I'm just going to take perfect squares. Okay, the perfect squares I know are, is 0 perfect square, are 1, 4, 9, and 16. Because if we think about it, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, and the square root of 16 is 4. So that's going to be an easy way. These are going to be easy numbers to plot. The square root of 0 is 0. So that's going to be the point 0, 0. The square root of 1, so we just take the x and put it under the radical. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. And we saw how for this guy, because we're squaring it, we're getting really big y values for small x's, right? And here we have big x values, small y values. So you're kind of doing this kind of thing, but you're putting it on its side. So it's going out instead of this one's going swooping up. This one's going to swoop out, and you can't do a negative, right? The -16 is going to be not graphable. So the square root function does not exist below 0. You cannot put a negative number here, so there's not going to be a graph over here, here, or here. Can't be below the x-axis. And you're not going to square a number and get a negative on the y-axis. Anyway, so we got 0, 0, we got 1, 1, and then we got 4. We got to go all the way out to 4 to go up to 2. And then we got to go all the way out to 9 to get up to 3. And then all the way out to 16 to get to 4. So this is just a very slow graph like that. Okay? That's the square root function. Absolute value function. Think about the absolute value of our small numbers, -2, -1, 0, 1, and 2. 0 and its neighbors, right? So f of -2 is equal to the square root of -2. The square root of -2 is just 2, right? -2, 2. -1 is going to be the same. It's going to be a +1. The absolute value of 0. How far away is 0 from 0? It's 0 away, 0 units away. Absolute value of 1 is just a +1. And then the absolute value of all your positives are just going to be kept the same, right? So what is the graph of the absolute value function? We got 0, 0. We got 1, 1. We got -1, 1. We got 2, 2. We got -2, 2. So the absolute value function is actually all my y's are always positive, even if my x's are negative. So it'll never be below the y-axis because the y's will never be negative. And then for x, even if my x is negative, my y is still positive. And it goes up in exactly the same. So basically over here, it's the same as y equals x, right? And then over here, we take y equals x and we just flip it across the y-axis or send it up in that direction. Okay, so that's the absolute value function. Reciprocal function. Remember that a reciprocal means you flip it across the fraction. So we had y equals x, the linear function, and then the reciprocal of the linear function is y equals 1 over x, because we moved x to the bottom of the fraction. First, we turned x into a fraction by putting it over 1, and then we moved it to the bottom of the fraction, so we call it the reciprocal function. So the reciprocal function of -3, -2, -1, 0, 1, 2, and 3. Ugh. Fractions. Good. And then graph it. So f of -3 is -1/3, right? So when x is -3, y is going to be -1/3. And I think we know where this is going. When x is -2, y is going to be -1/2. When x is -1, y is going to be -1. Good thing I'm writing this out. When it's 0, 1 over 0. What happens if you put 1 over 0? Does not exist. Okay, so that is a hole in your graph. 1 is going to be 1. 2 is going to be +1/2. 3 is going to be 1/3. Good, so let's graph these. I think the biggest you go on y is 1. I guess -1. All right, from -3, -1/3, -2, -1/2, -1, -1, 0 doesn't exist, 1, 1, 2, 1/2, 3, 1/3. This is an interesting graph. Okay, let's look at it in Desmos. So we saw that one, we saw that one. Now we're on to this one. What happens? It can't exist at 0. So these are two, each side of the graph is approaching 0 and approaching positive infinity on the y-axis. Okay, so it's getting really, really big on y. And then as it approaches 0, but it never touches 0, right? And then as the x gets greater in the negative x and positive x directions, your y is getting smaller and smaller and smaller and smaller and smaller, but it's never going to touch the x-axis. So that's an interesting graph. It's a hard one to graph, but basically you're going like this. You might be wondering, how do you know though that it goes up? Because if you get something that cannot be graphed, you can also take something close to that number and say, well, what is it doing right next to f of 0, right? So if f was 1/2, right? Then we would say 1 divided by 1/2 is 2. Good. So I know that when x equals 1/2, y is already 2. When x equals, and we get closer and closer to 0, we get a bigger and bigger number because that bottom of the fraction is going to become your whole number. When f is 1/100, it means we have to take 1 and divide 1 by 1/100, and we're going to get 100. So as we get closer and closer to 0, our numbers are getting bigger and bigger. Good? That's a way to check that. Or use Desmos. All right, moving on to 2 examples of piecewise functions. Make sure you understand this. This is complicated, okay? I should have made that bigger. I'll try to make that bigger on yours, the graph. A piecewise, oh no, let's not do piecewise functions yet. Let's review these, okay? Let's review these. So the ones we have done are, we did the constant, y equals, I shouldn't do it like that, okay? Constant, y equals 3 was our example, right? What does the graph of the constant look like? It just looks like this. You can't even see what I'm doing. Too excited. All right, so there's the constant. So ignore that, I think. Still formulating how I'm gonna write this out. After that, we have the linear. Y equals x, right? Y equals x looks like this. It goes through the origin, and then x and y mirror each other. So when x is 1, y is 1. When x is -1, y is -1, okay? That's our linear equation. You should be able to picture these in your head. When you see y equals x, you should be able to picture this graph in your head. When you see y equals and then just a number, you should be able to picture a horizontal graph through that point of y with a 0 slope, okay? After constant and linear, we have, I want to get the names right, the square function. Good? Square function because x is squared. Remember also that this is the same as f of x is 3, f of x is 2, f of x, oops, sorry, is x, f of x is x squared. Good? Y equals 3 is the same as f of x equals 3, just to be that reminder. Good? All right. X squared, it goes through the origin, and then it's rising at the same steep angle on both sides of the y-axis. After the square function, we have the cube function. Why is it a cube? Because now x is being cubed. What happens when we cube x? Instead of having a parabola in the upward direction, we have kind of half a parabola, and then that parabola goes on to mirror itself across the origin. That's the cube function. Then square root. Square root function, y equals the square root of x. Remember that that's only in this quadrant, and it looks like half of this, looks like we moved that over and cut off half of it, okay? Then we have absolute value. Because these are all functions, they can all be f of x equals x. Our absolute value is exactly like y equals x, except that there are no negative y values. So when the linear equation had positive y values, it mimics, the absolute value mimics the positive y values of the linear equation. And then for all of the negatives of the linear equation, we move those to positives. So all of these negatives now go right up here because the absolute value of x is going to be the same as x, but it's never going to be negative in the y direction. So the negative x's become positive y's for absolute value. After absolute value, what did we do? Let me see. And then we just did reciprocal. Reciprocal was f of x equals 1 over x. This one's a hard one, but what happens is we approach both the y-axis and the x-axis. I never touched. So those are the parent functions. When you see that, picture that. When you see that, picture that without graphing it. When you see that, picture that. When you see that, picture that. When you see that, picture that. You know what I'm saying. I can stop saying it. That's why I wanted to pause and review. So after that,